Let's review for the EOC STAAR test. Where is the 0? It is B. The 0 is another word for x-intercept, guys, okay? So it is here. 0 is another word for x-intercept. It's not A, it's not C, it's B. Function. Is it a function? Look at the x values. X is 1, x is 3, and x is 4. Do they repeat? No. So then it is a function. Okay? Let's look at this last example. This x is a 2, for those that can't see it. This is a 2. This is a 5. Do the x values repeat? Yes, they repeat. So is it a function? No, it is not a function. The best way to remember that, and I want to use a school-appropriate example, let's think about those young ladies that are sold. And it's a very serious issue, I know, in some countries. And they're sold and they're passed around amongst men. If they were to become impregnated with a baby, would they know who the father was? Probably not, because they have been passed around. So use that to help you remember. Too many, she was victimized too many times. The X repeated, so she doesn't know who the father is. Not the function. Not a function, not the father, okay? That's a serious issue that has happened in a lot of countries, but hopefully that'll help you remember here. This would be someone that's not in that situation, and X doesn't repeat at all. They would know who the father is, okay? Moving on. Dependent variable is Y. Independent is X. I told you the story to teach you this concept about your chores. Do I have to wash dishes? Do I have to fold the clothes? Do I have to take out the trash? Do I have to clean up my room? And why do I have to do all these things? And we kept asking why and why and why. And the answer is because you depend on your parents for a roof over your head. You depend on your parents for a place to lay your head and food to eat. So why do you have all those chores? Because you depend. So the Y variable is dependent. Remember, X is in the problem. For instance, Y equals 2X plus 1. The X is in the problem, so it is independent. Now, when you're looking at a word problem, if you're trying to figure out in the word problem which one is dependent or which one is independent, here's a helpful hint. Dependent always, 95% of the time in a word problem, is always going to be something about the total cost. The ending price, the total amount due, the total amount you're going to pay, or the total cost of everything. Let's go ahead and move on to the next example. I want to talk about X equals 1 versus Y equals 1. Which axis do you put X equals 1? I'm going to do that in blue. On the X-axis. What is the slope of that line? Undefined. Undefined. I use UND for abbreviation purposes. Now let's talk about Y equals 1. Do I look here on this X-axis? No. I look on the Y-axis where it is 1. And the slope of that line is what? 0. So be careful. If you forget, look at the letter in the problem. That tells you what axis to go to. So Y is 1, I go to the Y-axis. And the slope is 0. I want to show you an example real quick about this problem. Is this parallel to the Y-axis? Okay? So before you answer that, let's give an example of the Y-axis. There you go. That is the Y-axis. Now I want to put a line or a marker that is parallel to that line. So that's what parallel to the y-axis looks like. Now I'm going to use my hand or another marker to show you what y looks like when you graph y equals 1. Is this permanent Sharpie parallel to these? No, it's not. So my question, one more time, is this line, the pink line, parallel to the y-axis? No, it is not. Moving on. When you are solving for y, make sure to move the 3x over. You do the opposite. So he's positive. I am going to subtract him. No, this does not become 17. It's negative 3x plus 20. Bring down my negative 5, 1. Divide by negative 5. Don't forget that negative. So if it's negative, bring it down. Your final answer is y equals positive 3 over 5x for this one, because a negative divided by a negative is a positive, minus 4. Positive divided by a negative is a negative. Okay? If you're given a problem in standard form and you need to solve it for y, that's reminding you how to solve it for y. Okay? I want to show you how to graph this standard form equation just in case you forgot and you can't remember how to solve for y. Let's go to the calculator screen. So I do not want to save. I want to add a calculator. And then we are going to do, I'm sorry, add a graph. Why did I say calculator? I'm sorry, guys. Now we're going to go to menu, and it says entry edit. So I am going to edit the way I enter in my equation. Go to the equation, because that's what I want to change. And I am doing lines. This is a linear equation. And there it is, standard form. That code was menu 3213. Okay? Now I put in the coefficients. So that would be 3. That would be negative 5. And that would be 20. And it graphs it for you. So if you need to graph something in standard form without solving it for y, you can do this. Again, that code was menu 3213. Now I'm going to throw something in for free real quick. Let's say, for instance, that we want to make this an inequality. Or, let's say, for instance, you want to graph an inequality. How would you graph it in a graphic screen? I'm just going to show that for free. Add a graph. Delete the equal sign. And now you can choose. And then you just finish typing it in. 3 divided by 5, x minus 4. And it will graph it for you. Okay? If it's negative, you can do that too. Either or. Okay? Let's move on to the next example. How do I solve these inequalities for y? So I'm going to do negative 3x on both sides. The same thing we just did. Minus 5y, except instead of an equal sign, I have a greater than or equal to. Negative 3x plus 20. And then I am going to divide by negative 5. That will finalize and give me y is greater than or equal to 3 over 5x minus 4, which is what I just graphed. I put a negative on it at the end, but it was the same one. So let's go back and take that negative off so you can see what it looks like. Delete, enter. There it is. That's what that graph would look like. For this one here, subtract 3x. And if you know how to do this, just fast forward to the next part. You don't have to watch this, but I know some of you may really need to review. Divide by 5. Okay? So that is y is greater than or equal to negative 3 over 5x plus 4. And we can do that. Tab. And I'm going to take that out. Remember, when you delete The sign, it gives you the menu, so I can change it to greater than or equal to, and then negative 3 divided by 5x plus 4, enter. And look at that. Okay? All right. Moving on. In the calculator, let's review how to graph. And review deleting the equal sign. And we've already talked about solving for y. So one more time. Tab, delete the equal sign. There comes, there are your options to do inequalities, to graph inequalities. All right, remember you're going to be in the graphing screen on the calculator. Okay, what's next? When you have a word problem, make sure you graph any equations in that word problem and then hit Control T in order to look at the table. That will help you. For instance, if my equation is x plus 9, if I go to the table, Control T, I will see the points, and if there are points in my answer choice, this will help me. If there are words in my answer choices, this looking at the table will help. So remember, if you see an equation in your word problem, graph it and look at the table. How do you get to the table? Control T. Direct variation. I taught this long time ago, back in January, and we talked about when you do direct variation equations, it's y equals kx now. So when you see k, if there's a number in that spot, that's nothing but m. And it's m when the y-intercept is 0. How do I know? Because it goes through the origin. For instance, if I just type in 3x and press enter, look, straight through the origin. Straight through the origin. Any problem that you put in and it goes through the origin, any linear equation, it's a direct variation. Okay? Remember, k is m. M is k. K is slope. Now, if you are given a table and it tells you that it's direct variation, use menu 613 and find the equation. Control dock, let me add a calculator. Menu 613. Control right for the squiggly lines, 1, 2. X values. Okay? And then we do control right, 3, 6. Enter. Enter again. And it tells me y equals 3 for m, x plus 0. Let me say that again. Y equals mx plus b, and m is 3, b is 0. I don't have to write it. Okay, we're done with that. Let's talk about domain and range. For domain and range, if I want to know the domain, which number do I look at? I look on the x-axis and I look for the number that coincides with the point. Okay? Now, that means I'm going to have a line this way. Okay? Is the graph to the left or to the right of this pencil or this pen? It's to the left, so that means less than for domain. So x would be less than or equal to 4. For range, do you look at the 4 or the 3? Well, range means y value. So we would look at the negative 3, and we would draw this line here. So is that above or below? It is above. And above means y is greater than or equal to negative 3. Now let's find the domain for this problem. Is it negative 6 to 3 or negative 6 to 0? Remember, you are looking at the x-axis. So it's not 0. Oh, excuse me, it's not 3. It's not 3, it's 0. Let me say it again. Look at the x-axis. Is 3 on the x-axis? No, it's not. 0 is on the x-axis. So this is -6 to 0. Now, if you wanted to know the range, because we have to be prepared, we don't know which one we're going to have to find. The range is from here all the way to there. So the range starts at 3, and whatever this top number is, maybe it's 7. So the range would be from 3 to 7. But that's just a rough sketch that I made. Understand, the range, horizontal lines, from the bottom of the graph to the top of the graph. So that would be from 3 to 7. Look at the next problem. Okay, systems. Remember menu 3-2? Control doc. Okay, control doc. Add a calculator. Menu 3, system 2. Do you remember what to do with this? I'm going to change my letters to match the problem. So what kind of problem is this? We have cookies and we have fries. And I'm going to charge $8 per cookie. These are some big cookies. And I'm going to charge $4 for each package of fries. Okay? And I know I have a total of, I'm going to make a total of $25. Okay? I know that I have some combination of cookies and fries put together is a total of 6. I don't know how much of each. But when I put these two together in here for my cookies and my fries, I now type in the equations and press enter, and I have the solution. And that will tell me how many cookies and how many packages of fries that I have. Okay? Remember that. So $8 money goes with money. $8, $4, the $25 is the total. And 6 is how many items, so I'm counting the items when I do C plus F. Okay. Calculator screen tricks. Remember, menu 3-2 does the systems. Menu 6-1-3, you can write an equation of a line. So, how can I write an equation of a line with these two? I can do menu 6-1-3 for each table. When I do menu 6-1-3 for each table, it will give me my two equations. Menu 6-1-3, control right, parentheses, 1, 2, control right parentheses, 2, 3, because I'm doing the x's and then the y's. It tells me a syntax error because I had some stuff in here previously, so let's delete that and do it again. Menu 6-1-3. Control right, 1, 2. Control right, 2, 3. And this is y equals 1x plus 1. Now we do the next one. Menu 6-1-3. Control right, 2, 1. Excuse me, 2, 3. Don't make that mistake. Control right, 1, 3. And now I have y equals 2x minus 3. So with that, I am now going to do menu 3-2. I'm using x and y. Plug these in, and guess what? I get the solution. And I have to put y equals. So don't mess up and not put y equals. And there it is, 4, 5. Okay? So, if you were given a system by tables, use 6-1-3 and menu 3-2 together.